For homework 13, test 1, problem 3, we have a window with temperature inside, temperature outside, H value for the inside air, H value for the outside air, a window with a thickness of 1.4 centimeters with a K value of 1.4 watts per meters Kelvin. So they want to know what the heat flux is. To find the heat flux with different resistances, we do the delta T over R of these two temperatures divided by the total resistance. So right here we write our resistances. We have 1, 2, 3. We have the air inside, the window, and the air outside. For our given value, for the H value is 1. For the first resistance, the K value is 1.4 and H is 2.5. So for a convective flux, we need to use 1 over H. For a conductive, we use L over K. And for another convective is 1 over H. So we do 1 over 1 plus 0.014 divided by 1.4 plus 1 divided by 2.5. All of this gives us a total resistance of 1.09. We already know the delta T because it's 23 minus 4, which is 19, divided by the total resistance, which is 1.09. So then that gives us our heat flux. The second question is determine the surface temperature. So for that, we need to find the surface temperature. We need to find what the temperature difference is going to be. So we take the difference in temperature is equal to the heat flux times the resistance. We know the resistance of the window is 1. So 17.43 of that heat flux times the resistance of just the air is 1. So that equals 17.43 Celsius. The change. So to find the surface temperature, we do 23 minus that delta T, gives us the 5.57 degrees Celsius. For part B, we have to solve for what the heat flux would be if our enthalpy value was 1 over 3.5. So we do the same thing. We find our total would be 0.3757 if we change that H value. So with this new R total, it's just the same thing, the difference divided by the new total resistance, which gives us 50.57. Now that we have that new heat flux, it tells us what's the new, it's asking for the new interior surface temperature. So we do the same thing that we did here. It's going to be the delta T is equal to the heat flux times resistance. So delta T times heat flux times resistance of the heat flux times whatever 1 divided by 3.5 is, which is 0.2857. And that gives us a 14.45 Celsius. So we do the 23 minus that, gives us a new surface temperature of 8.55 Celsius. Now it's asking for what H value do we need to have so that it equals 18 degrees Celsius. So with this formula here, this is equal to a heat flux and this is equal to a heat flux. This is your delta T over your resistance total. This is your delta T divided by your resistance of the surface. It's 1 over H, but when you simplify it's H on top and divided by 1, so it doesn't matter, it's the same thing. So I'll solving it out. We have this H value, which we're trying to figure out times the difference of the temperature of the inside air and the surface, which is let's see, that's 5. So that's where we have 5 here, and so this is 23 minus the outside air, which is 19, You divide all of that by the total resistance. And we're trying to figure out the new H value, so we leave that as a variable, but we know these two values. So then we simplify over to this side. 19 over 1 over HI plus 0.09. And just simplifying it out, we distribute it and multiply this over, distribute again, 205 plus 0.45 HI equals 19, and you divide everything by, subtract 5 and divide by HI, divide by 0.45, and you get an HI value of 31.11, and that's in watts per meter squared Kelvin.